Hi, I'm RK here. Welcome to my new video. Today we're gonna talk about smart objects. So what are smart objects and what is this project? This is completely different projects from what I've been showing you past few videos. And I guess let's start from the beginning, from the background. I guess I'll put a timestamp in the description or in the comment, so you can skip the intro, but it's not gonna be long. So I suggest you to stay and listen for that minute. But if you're in a rush, then just click that timestamp in the comment and you jump right into the action. So okay, background. I've been making this game, right? Shadows of Serenity. It's an unannounced project, and all you as a viewer you have exclusive look into that project before it is announced. But I'm not gonna show you too much. But it's keep in mind it is kind of a secret for now, and it will have a few more advanced systems you might see, but it's not relevant to what I'm gonna show you today. Just keep in mind this is something not part of the tutorial. And in that project, I am making an AI system, and that AI system is tasked with managing characters in a shop QE. All right, so we have a shop. This is just a test level. I of course have a shop level, but I'm not gonna show you right now and at all before the game is announced. And in that shop, well, let's say I have a counter and I have a few places that I want NPCs to stand on and wait in line until they move on, and if they are right next to the cashier, they want to buy everything they picked and just get out of the shop. So I thought, what would be the best way, or maybe the simplest way to make such a system? And I thought about smart objects, because there was this topic about smart objects being used in UE5 early access with city sample and stuff like that. So smart objects have been used with state trees before, and I thought I would use them in my project as well. But I noticed that in the tutorial, in the official documentation for state trees, not state trees, in smart objects, in the documentation for smart objects, there is no mention about state trees. Right? The whole documentation is using smart objects with behavior trees for some reason, right? So I'm thinking like somebody reading this might think smart objects can be used with state trees, right? I made a few state trees videos. I probably should explore this topic a little bit further, right? And make a video showcasing how you can actually do that, and maybe make an updated Kickstarter guide for using smart objects with state trees. So this is what this video is about, right? So I have basically an AI system I wanted to make for my game. It's about state trees and smart objects, and this is just a kickstart guide on how to use smart objects with state trees. I'm not gonna go into details about how everything works, but on the other hand, it's not too complicated, not too broad. A lot of it is hidden in C++, and to use smart objects to its fullest, you would have to dig down in the C++ and do some configuration there. And if you would like to do that and share your thoughts, I would gladly listen. So if you know, if you experiment with smart objects in C++, please let me down below in the comments how it went and what did you learn. So let's start. Okay, it's 5 minutes 20 seconds. Okay, this is going to be a timestamp. So let's begin. What do we have in our scene? Well, basically I have a spawner that has basically character cards. Character cards, you can think of that like basically a character template we can use to spawn. And I'm gonna add it 2 because I want to spawn 2. But I guess for starters, let's just use 1. So this spawner will spawn 1 character of this class, and this character will go to that blueprint, which has a smart object component, and it will use that smart object. And well, I guess I should give you a little more information on what smart objects actually are. Again, not a thorough explanation, not a very long, big ass tutorial, just a short description. I'm just gonna stick to basics. Smart objects are not super smart, as you could imagine. I mean, even the smartest AIs are just a set of algorithms, but you can think of smart objects as you will think about smart pointers. So unique pointer is a pointer in C++ that holds basically a reference to a data. Well, actually, that's not the common part between smart object and smart pointer. But in case, of shared pointers, the shared pointer holds references to owners. And if there are no owners, it releases the resource, or basically marks itself like freed. And the same principle applies here. In a way, a smart object can be claimed, and if the object is claimed, no other AI or character controlled by the AI can claim that smart object again, right? So it can only have one owner, and when that owner is done with the smart object, it just unclaims it or releases it, and that smart object is again available to be used. And the second thing that smart object does, smart object has behavior built into that slot. Slot, yeah, because smart object has slots. Slots are part of a smart object, and you can have as many slots as you want. And each slot has dedicated behavior that your AI can use when it whatever reaches that point. So let's maybe see how that works. I don't think I broke anything past few hours, so let's try it. Okay, we have a character spawning. He gets to the smart object. He gets the behavior from the smart object, does it, and frees the basically smart object. You can enable the debug mode clicking apostrophe, and you will see the smart object if it's in use, if it's claimed, and yeah, quite a nice way to debug your artificial intelligence. So okay, how does that work in the background, in the backend. Okay, we have this object. It's called BP shop QE, and it basically just have a component called smart object. So it's of smart object class. I just pick this, add it, you have it. Also, I kind of forgot, but of course, with any stuff like that that is not enabled by default, you have to enable it in the plugins tab. So I guess let's go and see how it's called. First thing first, you need to enable smart objects. You have to enable that because you won't have that. So you need to enable smart objects so you can add a component and the definition asset. Then you need to enable gameplay behavior smart objects, which basically adds one thing you can notice, but it's also important. So enable that. It's experimental for some reason, but I don't think it's broken. Also, this is not experimental and it's version 0.1 for some reason, and this is experimental with version 1.0. So Epic has some issues with naming and generally documentation, so let's give him some slack. And the third thing you need to enable is AI and behavior. AI behaviors is this thing here. Don't ask me what it does, just enable it and it will be fine, trust. And of course, if you are using state trees and it's not enabled, you need to enable state trees. So gameplay state tree and state tree. So those two plugins, and you should be good to go to follow my tutorial and do this step by step. So okay, we have a blueprint that is basically another actor. We added a smart object component, and now we need to add a definition asset. So you probably won't have that smart definition asset, so just click smart object definition, and that will create a smart object definition for you. Now, when you open that definition, it will show you something like this, right? So empty smart object definition, and in this panel you can basically configure your default behavior for that object, and every slot will use that default behavior. Now, to actually have that object be interactable, you need a slot, so a place the AI will go to and use and claim and stuff. So to add a slot, just add an element. You can change the name. I'll just call it Q slot. You can change the shape, rectangle, circle, whatever color, and stuff like that. Then we have tags, whether it's enabled or not. You can, I think, do that in runtime as well. And yeah, data is interesting, so we'll get to that in the end of the video. And then we have behavior definitions again. So it's not now a default behavior definition, it's a behavior definition specific to that slot. So when an AI reaches that slot, it will use or it will check if the behavior definitions here is empty. If it's empty, it will just use this one. If this one is empty, you just get compile error. So don't leave this empty, probably. And now, as you could have noticed, we can have number of slots, basically arbitrary amount of slots. So if we want probably a car, maybe we have a car and the car has 4 doors, then we would just make 4 slots. And to add another slot, just click add element, name it like Q slot set the second, and then we can just set the offset. Lovely. And now you may think like, okay, we can add those slots, but I don't really see the context, right? So if we are adding those slots to a car, then we don't see that car really. So how do we do that? Well, basically preview settings. You can, pick a mesh, pick whatever the context is. Let's see, what can we pick? Maybe almonds, whatever. So now the object mesh path is almonds, and you can see the relative position of the second slot relative to that mesh. Or we can skip meshes and just use actor class. So for actor class, well, let's say maybe let's use this. Will that show anything? Wait, that's user preview. I should probably put that here. PC, yeah. And now we have a PC station. So yeah, we can change the offset of the second circle relative to that desk. And we can change also the first slot. So it's like that. And now we have a desk that basically has two slots. So if we had two visitors, they can use those slots and watch us play for your Twitch simulator game, I guess. But yeah, we don't need this for a Twitch simulator. So let's delete this and leave just one slot, because that's all we need. And let's continue. How do we actually make a behavior for that? Pretty simple. In that index, it will be, of course, empty. It would be just like adding a new behavior definition here. So the index 0 would be empty. You can just pick that gameplay behavior, smart object behavior definition. Holy shit, that's a long name. And that object is added by this plugin. This one experimental plugin. That's pretty much all it does. It's adding this class, so you can add it, right? Probably it does more, but you won't see anything more other than this. So yeah, pick this, and now we have something called gameplay behavior config, and that one is interesting one because you can make one yourself, but it will be very limited. It will be limited only to the behavior class. And I know for a fact that you can have some more options than this, but it has to be done in C++. So for example, we have some basic classes that are already made by Epic. We have config, animation, behavior tree, and if we pick animation, then we have some more options. But when we make our own GBC class, you make it basically typing behavior and gameplay behavior config. If you make a child class of that, then you end up with something like this. And actually, maybe you can script it. Let's say SO something. Let's try this. Let's try this and see if it works. Okay, it actually works. I kinda thought it doesn't for some reason, but oh well, you can add some parameters here. and enable them. Okay, I have no idea why I didn't notice that before, but I guess tired, maybe, that's my excuse, okay. And let's see what else do we have here in that case. We don't have any functions variable and stuff. We have a variable now, and if we have that, then can we pass it to the behavior class? I don't know. I didn't really check this out before, but now we are 20 minutes into the video, so I am not recording this again. So I mean, you have to deal with that, or just check it out yourself. Maybe let's continue as if that wasn't possible. Anyway, you can make then your behavior class. I have one class I made called GB shop QE or shop Q. Well, but I like to call it shop QE because it sounds better. And now that shop Q is basically a simple script that has a few functions, overridable, of course, on finish and on triggered, and those come in a few variations, basically an empty one, pawn, and a character. And all it does is basically checking if the owner is a character, and if it's a character, then you can use that avatar, and if it's not a character, then this will probably not be valid. And you kind of have to know yourself if you're using this with characters or just actors. If you're using it with actors, then just use on triggered, and it will the avatar will be of actor object reference, not character object reference. And yeah, this event is basically doing this, right? So yeah. Usually you don't have AI on actors, so probably this is the better choice, and it's cleaner, so yeah, just use this. And how do we script those behaviors now? Well, we pick the avatar, then we set it, so we can do some stuff with it, and this is also in the documentation. It's a basic example, so just get a skeletal mesh component from that avatar, play a montage on it. We have a basic attack montage, so not related to a shop QE, or maybe sometimes it is attacking customers, maybe in some parts of the world, probably happens. Okay, so I guess a relevant animation we got here. And when it completes or interrupts, we just want to end behavior. End behavior is a function from gameplay behavior, so we can just type end behavior, and it will show plug in an avatar, and you are good. So what it does is just play a montage and release the smart object when it's done. Simple as that. And maybe let's give it a few minutes, I guess, and see if we can cast this to a config. Well, I don't think we can. Maybe we can kind of type it. Just type it. So, kind of disappointed that would work. Data also is kind of empty. So one thing I'm still missing is how do I access those variables from the gameplay behavior, because that config really doesn't do much for me right now. Oh wait, GBC, did I? Probably I typed that wrong before for some reason. But okay, we can now cast it to GBC shop QE, and now we can access SO something. Okay, lovely. So we can do that, and that is cool. That is cool. So I guess just, add some parameters here if you want, and then just cast the config to your class and access those variables, and you can use those parameters in your behavior class. So lovely. But in our example, we don't need that right now because it's just the kickstart guide for, a very, very simple developers that don't need too much functions. I'm just kidding. But I don't want to drag it to be 1 hour long, which it probably will end up anyway. So let's just continue. Now we have a behavior that is going to be used here, and it's again a default behavior definitions. It will be used for all of the slots, and if you want to override a gameplay behavior, then you just do this, do that, animation, whatever, something else, and just every other slot will use this, and this slot will use this. Pretty simple. Okay, so maybe for testing purposes, let's add another slot. Let's make it like that maybe, and let's add another character. Let's call it this one, and let's see how this works now. Okay, so it didn't crash, just my characters kinda like to stagger. Okay, so one problem we have right now is no avoidance. So let's fix it right now, real quick. Let's just enable RVO, and we should be good. Let's check it right now. We got this boy and this girl. Yeah, she's avoiding him, getting to the slot, and everything works as designed. Now they can sort of fight, whatever. Yeah, that. Okay, so we have a fight in a shop. Very nice. But how does it all work with state trees? Of course, I didn't show that, and that's the second part of that video. I promise it's going to be shorter. Don't worry. Let's go to the blueprint of our character, and let's just jump into the state tree. So I'm gonna show you how the state tree works for that artificial intelligence. We don't have much. If you don't know what state trees are, I really am not sure how did you find that video, but anyway, I am MRK, I do state trees videos. You can watch them on my channel. I have dedicated playlist for that, so check it out. And when you do, come back here. So we have standard things, context actor. I just pick that customer and make a new state tree task. Well, 2 tasks, but the second one is just a stock delay task. Just waits. And in our state tree task, we have this STT find place in QE, and it's this. Not very not complex. It's just used to find the smart object handle. Well, smart object itself, and then get a handle and claim it. That's all it does. So find the smart object, use it, and when you are completed, go to wait and do it all over again. Super simple. And let's kinda analyze the task. Some things changed from the documentation, and even in 5.3 they don't say that, but they tell you to claim an object, but there is no node to claim an object. actually. So reading the documentation while using 5.3 can be a little bit confusing. So let's see how we do that in actually 5.3. So first thing first we do is, overriding enter state event. So a simple, beginning for a state tree task. Then we need to find smart objects, and we do that by using a smart object subsystem. If you enable the plugin, you will have it here. Just type smart object subsystem, and get that. You have that, right? And it has a node find smart objects. So we plug into to this. For user actor, we just want to use a context actor. You already know that if you watched my state trees videos, so I'm not gonna explain that. And for request, we have a smart object request. Basically, we make a smart object request for query box or query box, I think you say it. We just make box from center extents because it's the simplest one, and if you would want to make a debug box, then it also uses extents, so you can just plug this here, and you're done, right? So yeah. For debug purposes, super easy to use this node. This is of course self-explanatory, really. I won't explain that. And now we do make smart request filter. And I think that in the future we will have more behavior definition classes, but for now we just have one. So this is kinda useless, but we gotta do that for it to work. And in make array, we just enter the one class that our plugin added, gameplay behavior, smart object behavior definition, blah 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 blah, and we good here. All right. So now we have a smart object node that returns smart objects. Well, array of smart objects it found. There is also another node for that, and it's called find smart object. But there is an issue here. An issue that we don't have a return value bool, which is kind of weird, but this is better. Use this. But this also exists if you want. Okay, so we just check that return value. If you found some objects, if you did, then you take the first one, or we can make an algorithm to pick a smart object. We can do random array item. We can do I don't know, sort that array by distance, and then pick the closest one. So this node probably, it's a sandbox. Do whatever you want. And then we break smart object request result, and we get two handles. We have smart object handle, which we cannot use for anything, really. And we have a slot handle. So slot handle, yes. We get slot handle to that little slot, yeah. Family-friendly content, yeah. Yes, this is a slot. We get it, or we get a handle to it, and now we can mark this smart object slot as claimed. So this is the difference from the documentation. In the documentation, they just tell you to type claim, and that node, just pure claim, isn't there. So you have to use this node. And for user actor, we actually want to use context actor again, but I guess it works with a controller too, so doesn't matter, I guess. And then we check if the handle claim handle is valid. So did you claim the smart object? If yes, then just, yeah, it's valid. That should be a branch. And then we have a task. We basically have two tasks that we can run. One is use smart object with gameplay behavior, and the second one is the one you see here. So we can kind of pick what we want. So do we need to get to that smart object to use it, or do we not? And we just claim it before we reach the location. In our example, we need to reach it, so we just move and use. And when we finish using the smart object, we just finish task. And if it fails, then we of course finish task with succeeded false. And that finished task, available from Unreal Engine 5.3, just finishes that task and puts our in wait state. And that wait state, of course, goes back to root, and that goes back to find place in QE. And that's pretty much it. Very, very much not complicated, quite easy to use. And yeah, I will use that for my game, and you should probably too, because this is easy, nice to use, kind of like smart pointers in C++. So really, no, I don't see any downsides. And if you need, then you can also use that BP, so you can have a full force of the actor blueprint, because in our, what was it called, shop QE, right? We also have smart object owner, so we can just cast to shop Q, so that object, and yeah, get whatever we want there. So more advanced than I thought initially. And you can use that to actually count references, because you can get slots from C++, but I really didn't find any way to actually check if those slots are used or not. Maybe it's there, maybe I just didn't see it, which is possible. Let me know in the comments below if you saw that, but from what I saw, it's not really possible. So I would use that shop QE to actually count references and store them. And if we had a bench or a car that has to have 4 slots filled, then yeah, just on claim, cast to that object and increase the reference count, something like that. So okay, so that was my final words on that. I think very, very, very nice. If I missed something, or if you want to know more about some things, or you find something interesting and want that topic to be discussed by me, then please feel free to comment down below. And if not, then just drop a like, drop a sub, hit that bell button, or whatever YouTubers are saying these days. Just do that, I guess. It's fun. And that's it. See you in 2 months probably. Unless I find something interesting again that I can show you. So yeah, that's it from me. Have a great day and see you next time. Bye bye.